are welcome to session 3 of Unit 3. And in this session, we'll be looking at common graph forms in physics. My name is Patrick Eji. Now, at the end of this session, you should be able to know some of the common graph forms that are used in physics, and also explain the relationships with equations that exist between these common graph forms. And finally, state some physical or physics laws and concepts that exhibit the types of graphs that are being presented. So now let's look at working with graphs as a student and as a physics teacher. And as a teacher and a student, we must understand and know that graph is a powerful tool that helps us in presenting data as well as interpreting such numerical data. And in addition, graphs and knowledge of algebra can also help you as a teacher and a student to find the relationship between variables that are plotted on a scatter chart. And so the art of interpreting, the art of creating and employing graphs is an essential skill in the sciences, especially in physics, where relationships need to be derived. And so as a teacher, as a student, you should be familiar with the typical forms of graphs that will appear in physics. And the graphs that are likely to appear in physics, one of them is a linear graph. And so let's take a look at the graph that has been presented here. And over here we have a linear graph, so a straight line graph, also known as a linear graph. And when you look at this line graph, you realize that we have a straight line which is passing through the y-intercept. And we can find the best fit. Normally we find the line of best fit in physics. And you realize in physics you'll be told that, or you will tell your students that the line of best fit, at least such a graph should pass through at least 3 of the points if you have plotted 5 points. And when you observe this graph, you observe that the graph is cutting the y-axis at 0.5. At 0.5, as we can see from the equation that is being given. It is cutting it at 0.5. And so because this is cutting it at 0.5, we can say that and know that looking at the graph, when you observe carefully where we have the 0 mark, you realize that the linear graph we have here is cutting the x-axis at the 0.5 because the intercept is giving us a negative 0.51. So when we continue, we are going to get that particular point. But how do we define the relationship between the x variables as well as the y variables? And we can do this with the equation of a straight line, which we know in mathematics that the equation of a straight line is given by y is equal to mx plus c, where m is the slope and c is the value on the y-intercept. So here, that is when we take the value of y when x is 0. That will give us the intercept. And the slope m in the graph can be found using changing y over changing x. That is y2 minus y1 divided by x2 minus x1. And that will give us the slope that we have on this graph, which is 1.84. Now, when you compare this equation, y is equal to 1.84x minus 0.51 to the equation of a straight line, then we can see that the slope, which is m, is 1.84 and the intercept is negative 0.51. So the linear graph is also, or the linear graph, which gives a linear relationship, is one form of graph that we are likely to meet in physics. Another graph is the inverse relationship. And this graph is of the form y is equal to a divided by x, or xy is equal to ay. Now, such graphs can be the graph of pressure and temperature for changing volume at constant temperature for a gas. And a typical of such is the Ball's law, which talks about the pressure and the volume of a gas at constant temperature. And such graphs have this nature. So when you look at this, this is an inverse graph as one of the variables. So over here we have, when you look at the form, we are saying that y is equal to ax. In other words, y is inversely proportional to x. And so the inverse relationship kind of graph is another form of graph that we are likely to meet in physics. And we also have the inverse square relationship as a form of graph. And this is of the form y is equal to a divided by x squared, or y is inversely proportional to the square of x. And so characteristics of such graphs is the Newton's law of universal gravitation, as well as the electrostatic force law, or the Coulomb law. And we know that the Newton's law talks about, so F is equal to Jm1 m2 divided by r squared. That is, talks about bodies of masses, whereas the Coulomb's force law, or the electrostatic force law, talks about charges. And we can say that these two equations that we have here are all inverse square relationships. And graphs of this nature are the graph that has been shown here. Now, students, in this session, we looked at common forms of graphs that we have in physics. We mentioned the linear relationship form of graph, the inverse relationship, and the inverse square relationship. Now, as we bring this session to an end, for each of the graphs that has been presented below, it means I'm going to give you some kind of graphs, and you have to state the relationship between the x and y values, and also state an example of the characteristic. And once you state the example, you must provide an equation that exists between them in the following graphs that are being given. And so this is graph number 1. You are to state the relationship between the x and y variables. And graph number 2, you do same. Thank you very much, students, for joining this session. See you in the next session. Bye.